last time. Um, so yeah, this was homework number 24, I think. Yeah. Look at 9.8, just to kind of jog your memory a little bit. Let's say you got two figures that are similar. So we'll call them A and B, and the scale factor is 2/5. Do you guys remember what the ratio of the areas would be? Would it be the same ratio, or do you have to do something different to that number? You square it. Good. There you go. Perfect. Good. You guys remember. Awesome. So 4/25 would be the ratio of the areas, just so you know. Okay, good. Because we're going to do the same thing in volume, right? Now, what the perimeters was 14/1. Well, perimeter is the same as this, right? Because if perimeter is just one dimensional. So if the scale factor is a certain number, the perimeter scale factor would be the same thing. So if you want to find the ratio to areas, what would you do to that number 14/1? You'd still square it, right? And of course, use a calculator if you need to, but it's 196. Now, if you go the other direction, what the area has that ratio? What would be the ratio of the perimeters now? What would, what would you do with that number? What's the opposite of squaring? You root it. So it's 9/1, right? So let's make sure you're comfortable with going back and forth and this is the other direction, right? So that was just some just review, jog your guys' memory a little bit. So that's good. You guys are great there. Ooh, that's a good one. So it's hard to tell if you're sitting way in the back. Let me zoom in a tad more. Yeah, so you got like the a circle inside of a square, right? And you're asked to find the area of the shaded region. Of course, you do need to know some dimensions. So they tell you the length of the side of the square is 6. If that's true, how long is the radius? Yeah, good. So what would the area of the square be? How would I find that? If all the sides are 6, 6, 6, 36. What's the area of the circle going to be? You guys remember the formula for that? Good. Pi r squared, which is 9 pi. And pi is roughly what value? We had pi day recently, right? 3.14, right? So multiply the 9, it's about 27 and some change, maybe 28. So it's definitely less than 36. So if I want to find the area of the shaded region, now look at the shaded region, right? It's only two corners here. It's not all four corners. How would I determine that based upon the information I have now? Okay, good. Yeah, yeah. Y divided by 2. Correct. If you just did this, then that would include these as well. But since those are not included, you got to cut that in half. Good. I like that. Okay, good. So that's just more geometric reasoning, some methods you have to use. Um, this one here. If you're asked to find the area of this diagram, it's kind of funny, right? You can do it a couple ways. What's one way you could do it? What's a thought you guys have to approach this diagram? Reagan, go ahead. Yeah, yeah, 100%. I would totally do that. So you can make three rectangles and one triangle. Now, if that's 30, this has to be 15. How do I know that? Correct. And this right here is a funny value, so 15 root 3, because that's always root 3 times the shorter leg. And one thing I could do actually to make this a little more manageable is maybe chop it up this way. Because then how long is this side going to be? If 15 was a whole bottom and 15 is a little part of it, what's left over for that remaining portion? You agree 36, right? And oof, this gets a little tricky here. If that's 36, what do you think each of these are going to be? Yeah, good. Because that's chopped up equally. So 12, 12. Ugh, this gets really nasty. If that's 12 and that's 15 root 3, then let's get a different color here. How long would that one be in green? What do you guys think? Yeah, 15 root 3 minus 12. You have to subtract it. I trust you guys could do the rest of the calculus afterwards. I'm not going to compute it. All I care about is that you guys know the method. That's all that matters to me. Um, Another way you could do it too is you could have connected that and assumed that this wasn't there. What do I have now? the trapezoid, right? And that's a funky form of B1 plus B2 over 2 times H. But once you do that, you do have to subtract from that little square that was pulled out, which is 12 by 12, and you're fine there also. So, but you still had to figure out what this was, right? You can avoid that. But yeah, just a few ways you could do it. Um, I don't worry about part B. Let's move on. Okay, going back to three-dimensional geometry. How would you handle a problem like this one for 926? You do a couple ways. Split it again. So it's kind of so I like to do these little dashed line thingies, right? And you realize, okay, well, I have two prisms. Find the volume of each prism, add them up. So if you think about the area, the volume of a prism is the area of the base times the height. We're going to review that again today. Um, let's look at this little guy here. Let's say you call the 4 by 3 the base. So that would be then 4 times 3 times 5, or length times width times height, right? Pretty simple, right? And that's going to be 60. Then for the other one, that's 6. That's not going to be 10 the whole way because that's going to be 6 by 6, but it's 5 wide. So that's going to be 6 times 6 times 5, and just add them up. So totally fine that way. Totally do that way. Another way you could do it too is actually try and make this a more complete prism and subtract that imaginary one I just drew. So in this case, it's 6 times 10 times 5, which is 300, but then take away that little one, which I know is going to be 60. So that's yet another approach you could take as well. That'd be 240. Either way is fine. What else we got? Yeah, I said do that problem. Find the perimeter. Just a review of old stuff. So the beauty about CPM is that they do review old stuff. And the one thing about the spring semester compared to the fall semester, and I will say this not to scare you, but historically, the spring final exam, I don't know about geometry. I can't speak for that. Algebra 2, I probably could speak for that. Spring finals tend to be pretty brutal, mainly because we come back at the beginning of January and you test at the end of May. January, February, March, April, May. 5 months of material. And throw in a break in February, throw in a break in April, and a few other things and distractions, beautiful weather. It's hard to remember stuff, right? You're going to forget things. And that's why final exams sometimes can be a little daunting, especially in the spring, because it's just so drawn out. So I like these kind of problems because it helps you to refresh your memory. Oh, I remember this from 2 months ago. Because the thing I don't want for you guys, I don't want you guys to get to the middle of May and like, oh crap, I got to remember 5 months of material times six other class, 7 other classes, right? That's crazy. So we want to make sure we're reviewing old stuff, like recycling these things over and over again. So in case you guys forgot, how would you find the perimeter of this? And perimeter meaning I got to add up these two sides and then also add that arc length. Do you guys remember how you do that? Clay, you have an idea? Hmm. Hmm. Okay, why divide by 12? Yeah, well, first of all, find length, not area. So let's do this. Let's do 2 pi times 6 divided by 12. So what this does, that only gets me this part right here. So because I have to do circumference. Why circumference divided by 12? Because, right, as you said, isn't 30 a 12th of 360? Right? That's if you're like if you bought a piece of pizza and cut it in 12 slices, it look like that. Because 30 degrees is goes in 360 12 times. So whatever that is, that's pi. And then plus the other two sides here. So it's actually 12 plus pi. That's why it's d. So again, just reviewing old stuff, right? That's good though. I mean, it means you guys are retained it, right? Um, and then I kind of don't want to do the last problem. Let's look at this one here, 933, if that's worth it. Yeah, kind of. It's a good one. If the area of triangle ABC is 96, oh, it's a mid-segment. Got it. Okay. What does a mid-segment mean? You guys remember? Faith, go ahead. Hmm. Yep. They'll be parallel. Yes, DE is parallel to BC. So it means they're similar. You weren't told that, but you can assume that because if these are parallel, those sides are the same. Those angles are the same, sorry, and they share that angle. Now, if 96 is the whole thing, see, we know that AD to AB. AD is this guy, AB is the whole thing. What's that ratio between those two? 1 to 1 to 2, right? So what would the area of the, sorry, what would the ratio of the areas be? 1 to 4, correct. And if the big one is 96, then guess what? You just have a proportion and you're home free. You could totally solve it. So that's what you could do. And I think that would be 24. So that's another one that we want to just keep reviewing over and over again. So I'm going to be more intentional about it so you guys are successful. Because to be honest, that's why we actually, that was a motivation for choosing CPM, in case you guys are curious. For those who came from middle school, you did CPM in there as well, because we were noticing this is an issue with retention. So CPM does a really great job of that. I think CPM has some other issues. We try to fix that with like, not enough drill and kill and a few other things, but for the most part, I think they do a good job of reviewing old stuff. So, okay, cool. So now that I've jogged memory a little bit, now let's actually talk about notes in front of you. So we'll do the notes. Once we finish that, remember we have 75-minute classes today. Then I'm going to have you guys work on this packet that you see over here as well. So you have two things in front of you. You have notes and a packet or a list of problems. The list of problems we'll do after you do the notes. And then there will be a Delta Math assignment as well. So got quite a bit going on here. So welcome back. All right. Okay, so let's go over the notes here. All right, so examine the 1 by 1 by 3 solid at the right. Build a solid with, we won't build it. Let's just keep moving. If the shape is enlarged by a linear scale factor of 2, how wide will the new shape be? How tall? How deep? How many 1 by 1 by 3 solids would you need to build the enlarged diagram? Use blocks to prove your answer. And what if you enlarge it by 3 and so forth? Yeah, so let's actually, yeah, because I don't have the link for that. So let's just think about it. If you enlarge it by a scale factor of 2, so you definitely have a block down here, right? You guys would agree? Definitely have another block over here. You agree as well, right? And also, if we're going 3 deep, but your scale factor is 2, how deep are we really going now? So is it 3 deep or 6 deep? 6 deep, yep, 6 deep, you got it. So that's how you could draw it. So instead of a 1 by 1 by 3, it now becomes a 2 by 2 by 6. So how wide? 2. How tall? 2. How deep? 6. So in this case, you would need how many of the 1 by 1 by 3 solids would you need to build? Well, if you think of 2 by 2 by 6 is 24, and 1 times 1 times 3, of course, is 3. So we increase by how many times? 8, yeah. So we call it 8. We call it 8-fold increase, meaning we multiply the volume by 8. And why? Because if my linear scale factor is 2 to 1, then what's my volume ratio, guys? 8 to 1. How did I alter the first ratio? I rose it to what power? Third power, correct. And why 3? Because you have 3 dimensions, right? So this is the key idea here. Don't forget this. Volume ratio is always the cube of the linear scale factor. Why? Because you are changing 3 dimensions in a consistent manner. So just cube the linear scale factor. That is the whole essence of this lesson today. That is it. Just recognize that. So if you can see that and visualize that, and that's what the whole part of the e-tool was, but I don't want to click on the link. I don't want to find it. I don't feel like it. So I think hopefully you guys can visualize, trust me, that's what's happening. So if you double the length, width, and height, or whatever depth, yeah, you're actually increasing the volume by 8 times as much. So same thing, part C, 1 by 1 by 3 solid. It's enlarged with a linear scale factor of 3. Okay. So now you're tripling all the sides. How's the volume change in this regard? If you're tripling the height, tripling the width, tripling the depth. Remember, we did 2 raised to the third power. So now I do 3 raised to the third power also. What's 3 raised to the third power? 3 times 3 times 3. 20, there we go. It's 27. So what if, how many times larger, it'd be 27 times larger? The volume. Because you're doing 3 raised to the third power. So that's it. So you need 27 of those. Because you're doing 3 times 3 times 9, which actually would wind up becoming 81. If the volume was 3 originally, now it becomes 81. Clearly multiply the original volume by 27 to get to the new volume. So now it's now 27 times. Okay, hopefully that makes sense. Where it does get a little dicey is when we start asking to compare the volume and area ratios. That's where it gets a little tricky. We are going to cross that bridge later. I don't know if we do that today. I'll have to look at these notes. And I'll just be honest with you. It's the first time I'm looking at these notes in 2 weeks, so I didn't do any work during the break. So if I make mistakes, correct me if you think I'm wrong. But I don't know. I think I do this on the fly. Anyhow, 943. At the movies, Maurice counted the number of kernels of popcorn that filled his tub and found that it had 320 kernels. He said that next time he'll get a large tub that is similar, but has a linear scale factor of 1.5. How many kernels should the large tub hold? Okay, this is the part I think it's really so important. I know it's very subtle. I would argue, some people might disagree with me. My colleagues might disagree, but I think that's a key word. Because what are you filling? A tub, right? What does a tub hold? Stuff. How do you measure that stuff? Like, let's say you have a tub, you have a bathtub, right? You fill up the tub, you fill it with water. How, what does that measure? What are we measuring? Volume, exactly. It's three-dimensional. It's the same thing. It's a key word because you're dealing with volume or space, right? I mean, space could be two-dimensional as well, like how much space in this room. But I'll tell you this, if the ceiling was lower, we'd feel pretty cramped, right? So who cares that we have 2,000 or whatever, 600 square feet in this room? That doesn't matter. If this ceiling was like 6 feet tall, that would suck. That'd be terrible, right? So high ceilings are a good thing, right? So we got to look at all 3 dimensions. So you think about space or capacity, right? That's what matters here. Like this little cylinder here, what if it was like only yay high? Like then I don't have as much teeth. I'm not happy, right? I need more teeth, right? So anyway, that's what's happening. So 320 kernels, 1.5 is a linear scale factor. So what's the volume ratio going to be? What do I do with that number? Yeah, and that's now, I know squared is 2.25. I'm not going to do that in my head. So yeah, you better cube that sucker. So 1.5 raised to the third power is going to be 3.375. So if you decide to go 50% bigger tub, you're gonna have a lot more popcorn, right? So whatever that is times 320 times 320, that's going to be 1,080. So if you're at the movie theater and maybe you're there with a few friends and they try to sell you on 50% bigger, like, I don't want 50% more. No, you get much more. You get triple, more than triple the amount of popcorn if you get a 50% bigger tub. It's also they charge it likewise as well, right? Like if it's a normal tub is like $5, they might charge 15. Like what the heck? Only, but there's a reason why, because they're giving you more food. Um, so that's kind of interesting. Actually, we should do a field trip to the movies now. Just kidding. That'd be fun. But maybe I'll try to find prices and that we can compare because that's kind of a cool thing. Like looking at soda, all these things. 944. A scale factor of two figures A to B. What's the ratio of the perimeters, ratio of the areas, ratio of the volume? So now we know what's going on, right? It's still A to B for perimeter. It's A squared to B squared for area and A cubed to B cubed for volume. And as I was saying, we are going to eventually look at situations where if I give you the volume ratio, give you the area ratio. That's a little tricky. You're always going to have to come back to linear scale factor to connect area and volume. Just say that. Okay. Any questions? Cool. Let's keep on moving. All right. Yeah. Sure, of course. Yeah. All right. The next page is blank. That's lovely. So now let's talk about so you got Ben Franklin here. It's kind of funny. We're now talking about the 250th anniversary of the country. Um, okay, I'll read out loud here again. A statue to honor Ben Frank will be placed outside entrance to Liberty Bell Exhibit Hall in Philadelphia. Designers decided that a smaller, similar version will be placed on a table inside the building. The dimension of the life-size statue will be 4 times those of the smaller statue. Okay. So the dimensions of 4 times. Okay, so that's your linear scale factor. We'll call it LSF. That is your LSF. Planners expect to need 1.5 pints of paint to coat the small statue. Okay. They also know the small statue will weigh 14 pounds. Okay, so that's, you know, like how much capacity it takes, right? Um, I mean, I know mass is a little different in volume, but anyhow, um, how much paint will be needed to paint the life-sized statue? Okay, so expecting 1.5 pints to coat the small one. So how much paint? You have to consider volume. So what's the volume ratio going to be? How do I figure that out? I have to cube it, right? But cube it, what do I get? 64 to 1. And how many pints of paint is needed for the small statue? They tell us. So what do you do? What do you do? What are you going to compute? 64 times 1.5, which should be 96. So you need so much more paint compared to the small statue because all the dimensions are increasing fourfold by 4 times. Um, so if that makes sense, right? So you have to consider volume because how much paint, that's volume. If the small statue is made of the same materials as a large statue, okay, the reason why they say that, um, have you guys learned about only a handful of sophomores, but you guys learn about density or probably just in general, if you just took science the last few years, what is density? Yeah, mass over volume, right? For those who, so why do we say that? Why does that matter? Because you want the same density. I know it's not science class, but I think it's still have a good discussion. So it just means because what if we went from bronze to nickel or platinum or silver or gold or whatever, right? Obviously that changes things, but anyhow, so what it means is that the weight's going to follow the same thing. Then its weight will change just, yeah. So that's why it changes the same way. So how much of the life size? Well, you just do the same thing again, 64 times 14. So it's going to be crazy heavy. 896 pounds. And don't worry, I'm not going to do this to you guys. I won't like say, oh yeah, the density now changes. Like this is not a science class, even though I think it's a cool problem. I won't do that to you guys. But just so you know, that's why that phrase is there because you're keeping the same material. All right. Cool on that one. All right, let's keep on moving. All right, why don't you guys try this on your own? We'll check in a few minutes, work with the table group, and then we'll do another page, and then we'll do the other worksheet. So I'm going to freeze right now. And speaking of oil, with all the stuff going on in the world, see what happens today. Trump threatened that he's going to wipe away the Iranian civilization if they don't open the Strait of Hormuz.
Serious?
Because like the Strait of Hormuz, where like 20% of the oil passes through, has been shut down since the war started. Yes, I spent $101 at Costco yesterday. I was looking at my Costco history. I spent $75 about 2 months ago. So I'm spending 33% more money in gas. Yeah, which is I think a bunch of bull crap. But
Wait,
but
but why do we want to take up that Iranian salt?
because Trump is crazy because they won't open the strait. But it's like, well, you attack them, of course they're going to use their leverage. Anyway, I don't want to get into politics. Yeah, I think so.
If they don't open it today, he's gonna.
Yeah, well, I hope he doesn't because I.
That's true.
So there's a little narrow passageway in Iran in the Arabian Peninsula where it's like the Panama Canal. Basically 20% of the oil, like oil that like China, Asia, and a lot of those kind of Russia, they get it from that passageway from the Middle East. And so that's been closed. So that's been a choke point. And so now all of a sudden gas is like crazy expensive, like the most it's ever been. And so now he's threatening to, but the things that why would they reopen it if they were attacking in an unprovoked manner? So
Wait, so what happens if we attack Iran?
I don't know. I think
What about
we're about to find out. World War III. No, I think we're fine. I think just we're feeling the pain with our cost of living. I am too. Like, no, I don't think I think we'll be fine. I and
We have more military if we wanted to.
anyway, sorry, I got us off track there a little bit. Let's get back to math. And talking politics is more fun, but anyhow. All right, so let's work this out. I'm gonna work it out too.
Wait, no, I know we like already skipped over this, but wasn't there like a freaking like uh what's it called? Like a warning for like the Bay Area from like Iran?
I don't know about that. I didn't follow that in the news.
Yeah, I'm pretty sure we like
You might be right. I don't know.
classroom talk about it. It was like when we had Pi Day. Everyone was like freaking out.
We can't tell if they're saying like, oh, it's the standard one. Yeah. 12,000 or if it's just a medium one.
This week, more.
So, it's not. I'm sorry. No, I just don't know that's right.
Okay, the first thing you want to do, guys, is do this. You want to do fun because they're saying the smaller one is four. So the smaller is 4/5 of jumbo. So the linear scale factor is 4 to 5, or 0.8 to 1, if you want to call it that. Once you do that, what's the next thing you're gonna do? Multiply that by what? Well, 12,000, because that's the capacity of the smaller, right? So now this gives the capacity of one jumbo. But how many jumbo models are we talking about?
Isn't the ratio 4 to 5?
No, it's 4 to 5 when you go from small to big, and you go big to small. Because we this so here's where this little tricky. This 12,000 is for the standard model. So you have to, that's why I did that.
It's fast.
Why 6/5?
Like, it's like it's 1/5 more than the regular model, so that's 5.
No, it's not 1/1/5 more. It's 5 to 4 more. So let's back up a little bit here. So if we look at the linear scale factor, let's think like this. Standard to jumbo is 4 to 5. So 4 over 5 cubed equals 12,000 over x. If you move things around, x is going to equal 12,000 times 5/4 cubed. I should probably have done it that way first. Why am I flipping that fraction? Because I have to solve for x. So if I move x to the left side, I have to move a fraction to the right side. I have to flip it, isolate x correctly. So it's just algebra at this point. And then multiply that by what number? So if you do 12,000 times 1.25, that's 5/4 as a decimal. Geez. 12,000 times 1.25 cubed. It becomes 23,437.5. Then multiply by 20 because you have 20 tankers. Times 20 should be a lot that you're shipping. That's a lot of oil that the world's not getting right now. No, I'll solve the politics. Yeah, but that's it. If a jumbo tank costs 50% more, which one's the better buy? Okay. Well, that's how many gallons. So if I think about it, that's a tough question. Actually, let's talk about the game plan for. Okay, first of all, does part A make sense? Are we cool with part A? So the linear scale factor is 4/5, but I had to flip and make it 5/4 because I'm going from small to big, right? If it goes from small to big, I got to multiply by the opposite of that fraction, right? And of course, for one tank, it's 23,437.5. So if you think about it, 12,000 times 2 is 24,000. So you need roughly 2 standard tanks. The reason I multiply by 2, and sorry if I didn't make that clear, that's my fault. If you think about it, what's the capacity of a standard tanker?
12,000.
What's the capacity of a big tanker?
20.
So it's roughly a 2-to-1 ratio, right? The capacity between the two. So you need 2 standard tanks.
Like two exact timeline. Two standard tanks equal one.
Correct. Right. So you need roughly 2 standard tanks to equal 1 jumbo. But does the jumbo cost twice as much? More or less? So it doesn't cost twice as much, because how much more did it cost? Let's say if a standard costs $1 million, the jumbo costs 1.5 million, right? So no, it doesn't cost twice as much. Does it cost more or less than twice as much based upon the information? Less. So which one's a better buy? The jumbo. So if you're an oil company, you prefer the jumbo. It's just more efficient to do it that way. So from a mathematical standpoint, what I should have done is I should have just compared the ratios between these two volumes and then compare the costs as well, see which one's a lower ratio. That's what I would have done. Now, what if the jumbo costs 3 times as much? Then I'm not buying the jumbo. I'll do the standard. Just give me a bunch of standards, right? Because it's more cost efficient. So you're really trying to compare the ratios properly. That's what you're trying to do here. So for part B, I kind of did it more with logic than anything else. Logically, you need 2 standard tanks to equal 1 jumbo. Does it cost twice as much? No, it does not. It costs less than that. So look at it from a common sense standpoint. That's what I'd argue for part B. Don't look at it from you could compare the ratios of the cost and the volume and see which one's a better ratio, but that gets a little messy at times. I'd much prefer to do common sense. So hopefully that works for you guys. Great. Okay, one last problem, then we'll do the other worksheet. Okay. Ooh, we're getting into some crazy stuff here. All right. So, consider the polyhedron shown. Its specific name is a tetrahedron. Tetra meaning 4. Is it a prism? Why or why not? Well, we'll talk about that in a moment. Assume dimensions of the shaded tetrahedron at right are half the dimensions of the similarly enlarged. Oh, right, yeah, go ahead. Sure, of course, yeah. Okay. So the volume of the large is 138. Find the volume of the small shaded tetrahedron. Okay. Well, it's still going to be, just so you know, um, the same ratio. Um, so first of all, I'll answer this question for you. No. Instead, it's a pyramid, which we'll talk about later in this unit. It's mainly due to the fact that you don't have quite what's the right way to think about this? You don't have the same number of faces. I think that's really the real reason why, but we'll explore it later. But for now, the volume ratio is still the same relationship with the linear scale factor. It's still the same relationship. So they say that it's half. So if this were x, then this would be x, right? If this were x, this would be x. So it's kind of like a bit segment, right? If this were x, this would be 2x. So that has to be double this. So what's the linear scale factor, guys? Between the small and big? 1 to 2. So if I cube it, I get 1 to 8. That's volume ratio. And if they said the large is 138, so volume of the small one to the big one equals 1 to 8. Cross multiply. I'm using V1 as a subscript to help me distinguish the small from the big. 138 divided by 8 should be 17.25. So volume of the small one is 17.25. Okay. And then if each face is an equilateral triangle, if the small shaded tetrahedron has an edge of 16, find its whole surface area for each of the tetrahedra. Okay. I think I would say for each face of the large. Yeah, I think the meant to say face. Let me write that more nicely. So yeah, um, if we think about it, the scale factor is 1 to 2. What's the area ratio, guys? What would the area ratio be? 1 to 4. So you have to square it. So it's 1 to 4. So if you think about for the large tetrahedra, there are 4 faces. So you need 4 times 64. Because what's happening, if 16 is a small, what's the big going to be? If I solve for that area, it should be 64. So that's going to be the new area of each face. And how many faces do I have? I have 4. So if I multiply that, I should get 256. I think it's square inches. All right, sorry, square centimeters. Oh, wait. Yeah, no, I'm right. Yeah, I got it. Oh, crap. Hold on. I made a mistake, guys. What does 16 represent? Sorry, I thought 16 was the area. My apologies. Um, shoot. Let's come back to the drawing board. My apologies. Okay, how do I find the area of the small face? What the 16 was? I thought the 16 was the area of the small face. My apologies. That was not true. What does 16 represent? The edge, right? If it's the edge, how do I find the area then? What do I have to do? You guys remember from doing hexagons? How does it get broken up? You guys remember? How long is this side right here? Yeah, and how about the height? Yeah, so my bad. So the small area, so there's a little extra work we had to do, is 1/2 times 16 times 8 root 3. That's 64 root 3. So 1 over 4 equals 64 root 3 over the big area. My apologies. I thought it was 16. So that's going to be 256 root 3. And you have 4 of them. So it comes 1024 root 3 square centimeters. And I caught myself when I put the units down. I saw this as centimeters on square centimeters. That's how I caught myself. So I thought the 16 was the area of the small face. I was wrong. It was just a dimension. So I had to find the area of the small face, then do the ratio afterwards. So it was a little more involved than what I initially thought. But it happens. I'm human. I make mistakes too. But like something like that, like as long as you see the connection, but you just forgot to do that part, wouldn't be too punitive, but you want to be mindful about that. Yeah, sure, of course, yeah. Okay, so we go till. Okay, so we got a lot of time still. Right. Okay, so questions on this? No, all right. So here's what we're gonna do next.
Oh, God.
Not right now. Maybe. Well, hold on. The schedule. Let's schedule on. No, on Thursday. Wait, that doesn't make sense.
Go.
Maybe. It's kind of cool. That's kind of neat that I'm surprised
It's a baby.
I'm surprised I only have one. But it is raining on Thursday, you're right. I don't know, there'll be plenty of times to go outside. All right. Anyhow, they're cute. Actually, when we were a one-story buildings, kids would actually bring the goats into the building. and bring in my classroom. Like, guys, you gotta leave the goats outside. Yeah, that's kind of cruel actually, because the mom gets distressed when the baby's taken away, right? It's not. It's kind of cruel actually, but kids used to do that, 10 years ago or so. Anyhow, let's look at this. All right. So there's 3 pages here. So just practice find the lateral area, the total area, and the volume. I'll do one with you guys just so you have an idea of what to do. And then there are 4 more questions afterwards. So this is just extra practice just to make sure you guys are comfortable with prisms. We'll see how far we get. I think we can knock this out today. And then there will be a Delta Math assignment as well. So number 1, really fast. Volume, super easy. Area base times height. That's just going to be 9 times 4. And the height's 9, of course. 36 times 9. 36 is, I think it's 324 cubic centimeters. Now, in case you guys forgot, lateral area is perimeter of base times the height. The reason why we do that is because it consolidates the process. Yeah, so good.
Sorry, hear about
Yeah, of course. Lateral. Lateral means side to side, right? Lateral movement for those who play, sports, lateral movements, especially football or soccer, that matters a lot, right? From side to side. How many faces make up the lateral area for this object? Yeah, front, back, left, right. I'm not gonna look at top, bottom, right? Just front, back, left, right. How many faces is that? 4, right? And what's the shape of each of those faces? Or rectangles, right? Yeah, some are squares, some are rectangles. Now, if you think about it, you gotta do 4 times 9 and 4 times 9 for the left and right. You gotta do 9 times 9, 9 times 9 for the front and back. Well, if you're adding up, if you think about it, don't write this down. If you think about it, you're doing this. You're doing 9 times 9 plus 9 times 9 plus 4 times 9 plus 4 times 9. So these are 4 faces, right? Face 1, face 2, face 3, face 4. Front, back, left, right. That's 4 products, right? Each of these products, what's common in each of these pairs here? What number do they all have in common? What if I factor it out? If you factor out 9, so factor, 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 what are you stuck with? 9 plus 9 plus 4 plus 4. What does that represent? 9 plus 9 plus 4 plus 4. The perimeter of the base. That's why you can do that. That is why we're allowed to say the base times height, give you the lateral area. You get away with that. Just to make it easy for yourself. If you want to find the area of each face separately, go for it. But personally, I think you're going to be grateful that we have this shortcut here. So if I do 9 plus 4, 9 plus 4 times the height, that's going to be 26 times 9, which, not damn head, is 234. And that's square centimeters. Lastly, for this one, the total area is a top and bottom plus lateral area. So it's 2B plus LA. Because now you're incorporating the top and bottom faces. Well, that's going to be 2 times 9 times 4 plus 234. So 36 times 2 plus 234. 72 plus 234. You should get 306. Square centimeters. So that's the process you want to go through. Perimeter times height, twice the base plus the lateral area, and base times height to get the volume. Okay. With that said, Let's see how number two goes. I'll give number two a shot. Hmm?
Okay, that's 2 and 9 times 4 plus.
Oh, I covered it. 234. Because 234 is what we got for the lateral area in green. Because when you're doing the total area, you want the area of all the faces. Now we got 6 faces. Left, right, front, back, top, bottom. Okay, go and try number two. See how you guys do. I'm gonna freeze the screen.
Right, so
Of course, yeah, yeah. Go for it. But I still have 2 more classes like this today. This is like so rough. I don't like the 75-minute classes. 100% I would agree with you. I think but you know what? It's the last one of the year like this. All the other ones are just normal 5-day weeks. True too, but you can always take a day off if you want. I'm just, I'm gonna take a day off on Friday because I want to, just, not this Friday. No, later in April. Yeah, because I need it just to take a break in the middle of the this long stretch. I think April 24th.
Same.
Like that bad.
I really,
I also like how the week goes by.
I'm not bad for it.
And like,
As a society, I think we should have 4-day weeks. I would 100% agree with you. I just don't think 75-minute classes though. It's wonky. I don't make the rules.
Nah.
Oh, we do? Oh, for Easter. Oh, yes, right. And then we have another one at the end of the year, as we do for the end of the year mass. That's true. Yeah, always right around graduation time. So,
There's like the assembly where like they show all the photos of like the seniors.
yeah,
The,
yeah, you got to do that. It's just good. Was your brother a junior or senior? Okay. Okay, just so you're cool with the volume, this is what I got for the first part of number two. You guys see how X is 10? That's Pythagorean theorem, right? And the base is a triangle, so you do 1/2 times 6 times 8, and the height of the prism is 12. Because remember, a prism has to be where you take a shape, and it's almost like you project it elsewhere, and that's a prism. And we got this from Pythagorean theorem, just so you know. So X we're good. Volume we're good. The lateral area, the perimeter base, 8 plus 6 plus 10 times the height, which should be 24 times 12, which is, oh, that's a coincidence. Also 288. That's a total coincidence that happened. And the total area, which is going to be the lateral area plus twice the base. Remember, the base is 1/2 times that. Should get 336. So this is the drill and kill that CPM lacks, and that's why we're doing this with you guys, because you guys really do need it to practice this. It's kind of like muscle memory in a way of sports. Like if you shoot a basketball 1,000 times, you get better at shooting a basketball. So, or swinging a bat, or swinging a tennis racket, or kicking a ball, whatever it is, right? So does that make sense for two? All right. Let's do three, four, five. We still got another 15 or so minutes. I think we can knock this out. I'm gonna do a start piece of paper and then may take a picture and project my answers. Um, yeah, so let's work this out. Let's go. So three, four, five. Ask questions if you're stuck. You can see how this incorporates some old stuff too from the previous unit. Four is a bit of a doozy. I'll show my answers in a moment. I'll come around and help you guys out too. You doing? Questions so far? It'll help. Yeah, yeah, good, you got the volume.
Okay, and how's it go, right?
No, this is a sausage triangle, but we're doing to find the lateral area, you have three rectangles. You have the right side,
Is it all right?
you have four rectangles, you have rectangle here, rectangle here, rectangle here. The lateral area on the sides,
Wait, then why does it say that?
given the right triangular, it's a right prism, just meaning the altitude forms a right angle
Okay,
with the base, that's all it means.
okay.
Yeah, don't confuse that. I can understand that confusion. I'm gonna scan in a moment. Let me just finish this up. Ugh, that's kind of crazy. Yeah, give me one sec, Alon. Sure. All right. I'm gonna take pictures of my phone. Upload it. All right, let's have a discussion here. Oh, I got emails to myself. Okay. Yeah, so let's talk about number three. We got a few more minutes here. So saw some of you guys got 840, which is great. The base is nice sausage triangle. Break it down, find the height, you should be fine. Getting base the base is 120, you're doing 1/2 of 16 times 15, multiplied by 7, that's the height of the prism itself. You get 840. For lateral area, I got lazy. I didn't find the perimeter, but it's fine. Well, actually, I got opposite of lazy. I did more work. But yeah, 17 plus 17 plus 16 is the perimeter, multiply 70 and 350, and then add the lateral area to twice the base. Yeah, that, but you can see the base is kind of the whole essence, the whole problem. Without the base, we're not, we can't get anywhere here, right? We need area of that base. Okay. No worries. So 840, 350, and 590 are what I got for that. I don't expect you guys to be totally fluid at this today. This is pretty challenging stuff. It can get even more challenging when we start throwing in similar solids and trying to find all the different ratios. But yeah, that's how I do number 3. For number 2, and I'll put this in Schoology as well. For number 4, yeah, go ahead, yeah. It doesn't matter. You know, 2 sides of 17 anyway, and just make sure you split it in half. Because when we're split in half equally, I need to have 17 on opposite sides.
Yeah. Okay.
I wouldn't split it any other way, obviously. Because I want to split it down the middle. But what does matter, that's it's up to you. For this one, this is an extension from the previous unit. So you have to find the area of the hexagon. So you have six equilateral triangles, right? The base is 12, or the length of the side is 12. The apothem, the height, we talked about 6 root 3. If you do 36 triangles, find the area of one of the triangles, multiply by 6, you get 216 root 3. Multiply the height of the prism, which is 16, you get that as your volume. For the lateral area, you have 6 faces. They're all rectangles. You can find the perimeter if you want, or just do 6 times 12 times 16. And then, of course, add the total area to the lateral area. Sorry, add the lateral area to the twice the base. You would get that. And just in the interest of time, just to show you really fast, we'll talk about this again tomorrow or Thursday. You have a trapezoid as a base. You got to find the area of the trapezoid. You got the perimeter, multiply the height of this prism, and then the lateral area plus twice the base gets you that. We'll review this again. And there'll be a Delta Math assignment. I think Mr. Davidson made one. I'll put it in Schoology later today. And yeah, that's it. We're all set. All right. Have a good lunch and good luck with the next 3 hours of classes. Crazy. Or 2.5 hours. Sorry.